Here's another application of macros. Very often, you're going to get multiple data sets that have the same basic format. More often than not, they come from different months or different mailings. So if you think back to Loyalty 1, the viewing data was sent to us by month. So I got something like 20 odd files, each one for a different month. Each one had the same format, and I had to read them in. Here's another example that's just like the air miles. I got some data from a catalog company at one point, and these were their mail tapes. So mail tape is a list of everybody who was sent each of their catalogs, and so this was catalog 171, 172, and so forth. And notice, of course, they're not going to be consistent with their names. That would make my life too easy. I guess I could have renamed them, but I just took the data sets that they sent me. Now, all of these files were DBF files, so that's DBase files, and I have to read all of them in. So I wrote a little macro function. Here is my macro function. This macro function takes a couple arguments. It takes the file name, and then it takes a number. So here's what I'm going to do. We're going to first put a title up. I'm going to use proc import to bring these in, and I haven't talked about DBase files, but this is how you bring in a DBase file. Then I'm going to do some stuff to each of these data sets, maybe create some new variables, assign some labels, only keep certain variables. And then the idea is I'm going to execute that macro on each one of these files that they sent me, then I'll stack them on top of each other. So this is a very efficient way to bring them all in. The alternative to this would be to have one proc import for each file, and then if I decide to change something, I'd have to go change it in each of those locations. So with a macro, you change it once, and you're okay. Here's another macro that I use quite often. Unfortunately, SAS doesn't compute adjusted standardized residuals for you when you do a chi-square test. It's one of the things I like SPSS better for, is the fact that they give them to you. Here's a little macro that I've written that computes adjusted standardized residuals for you, and it takes three arguments: the data set, the row variable, and the column variable, and calls up proc freak, sends the output to a new data set, then it does some math on that data set, sorts things, and then prints things. So that's another macro that I use all the time. And if you go back to my folder, there's a file. Let's just see, where is that file? Adjusted residuals out here that has exactly that macro in. So whenever I'm doing chi-square tests, I percent include that. Here's another task that I often use when I'm building a regression model. So if I have a kind of a data mining situation where I don't have a strong theory, and I have a bunch of candidate predictor variables. So here we were trying to predict who was going to respond to some catalog offer, and I had a couple hundred of these variables. I want to find out how all these variables are correlated with some dependent variable, in this case the log spend on some future amount. So what I'd like to know is what's correlated with them and what isn't, and how strong are those correlations. So this lists all the x's, all the candidate x's. It gives their correlations and then sorts them in absolute value of their magnitude. Here's the macro that does that. I call it doCore. So doCore has a couple arguments. I pass it a data set name. I pass it as many x's as I have, might be 100 of them. And then y is the dependent variable. What does this do? Well, it runs proc core. It suppresses the output but sends it to a file instead of to the screen. I get the variable names from proc contents, actually the labels from proc contents. I merge that in. I sort in descending order of the absolute value of the correlation, and then I print it. So that's another macro that I do all the time, and you're going to see in my folder a core macro that I percent include whenever I want to do this. So it's like I'm extending the SAS language by using these macros. Let's talk a little bit about loops. Another task that I often have is that I'm clustering some variables and I want to study different clustering solutions. So maybe I want to look at the 2, the 3, the 4, the 5, the 6, and all of those. And I could run proc fastclus multiple times. So I just have proc fastclus once, then have it again, have it again. But again, that's kind of poor style. So what I do is I have this do_clus macro. So let's talk about this. Do_clus takes 3 arguments. I give it a data set name. For example, cur.npdat was the data set name. Then I give it some variables, which I call var. So I was going to cluster on these 4 variables. And then I give it a maximum number of clusters that I care about. So in this case, it's going to be 8. Now, here's a do loop. So do I equals 1%2 ampersand n. What this means is go step I from 2, 3, 4, 5, 6, 7 up to 8. What am I going to do? Well, we're going to do proc fastclus with the data set I passed. I'm going to set the max iter and all that stuff. Then here's where I'm setting the number of clusters. I set the number of variables here, and then the %end ends the do loop. So it's just going to do this first for 2, then for 3, then for 4, 5, 6, 7, 8. Then %mend ends the macro. So this call would then generate those cluster solutions for me. Here's a more recent example. But by the way, that clustering, you've got a clus.sas out here that I %include in my bin. Here's a little more recent example. I was looking at air miles data, and this is actually part of an assignment. And what I wanted to do was first off run some means. Then I wanted to run a regression. So I was going to predict log tfreq1 through log tfreq4 as a function of tfreq0 and some predictor variable. And then maybe I want to restrict my cases somehow. All right, so on your assignment, I had you run multiple regressions. One was, for everyone, find out the effect of email. For those who responded to email, find the effect of opening it. For those who opened, find the effect of clicking it, and so forth. All right. In addition to running these regressions, I also wanted to run a different model. So this is called a Poisson model. It's kind of like a logistic regression, but the dependent variable is a count instead of a 0, 1. And you do that with proc genmod. Unfortunately, with genmod, you can't specify multiple dependent variables at the same time the way you can with proc reg. So I had to list out time period 1, 2, 3, and 4 separately as separate genmod commands. Now, if you go down here, here are the invocations. So I'm going to call up doit, and first off, we're going to use a universe wherever I know whether or not you got an email, which is essentially the whole thing. The independent variable then is going to be whether you got the email. Then this next line is going to be, let's just look at cases where people got email. So that's my new universe. And we're going to look at the effect of opening it, and so forth. Now, one other thing, you're going to notice this %str. %str just protects everything inside the parentheses. So email equals 1. If you didn't do this, the SAS macro language would think that you're passing it a macro variable called email and setting it equal to 1, but that's not what you're doing. You're passing the string emails equals 1, which then gets inserted into that where statement. So that's why I'm using that %str function. Now, the code I've just shown you is good, but we can improve on it. Because look, I'm doing exactly the same thing in these 4 calls to genmod. Why not stick that in a loop? So a slightly improved version would be do I equals 1 to 4, and then we're going to say tfreak ampersand I. And this executes 4 times every time I do it. So that would be a slightly better way to handle this. We've not talked about gains tables. Gains tables are like the decile analyses you probably talked about with Frank, but for predictive analytics models. Should you ever need a gains table, here is my macro that I've created to do it, and this is another one that's sitting in my bin. Few other miscellaneous topics. Sometimes you want to terminate a macro. So for example, here's a little function that reads in multiple files. So first we're going to read in file 1. And let's say that the name of the file is actually file1.csv. Let's see what happens to make this work. So we're going to pass file 1, and I'm going to make a data set called file 1. Now in the infile statement, I want to read from file1.csv, but if I say file1.csv, SAS is not going to quite know what I mean. So this first dot ends the macro. Then the second dot is the actual dot in the file name. So that's you use that double dot, the first one terminating the macro variable, saying, okay, I'm done with my macro variable, and then here's the file name. Do macros have arrays? The answer is kind of, in a very kludgy way. So let's say, for example, x1 is 1, x2 is 2, and so forth. I wrote a little macro here that has a loop where I run this and then I put them out to the log. It's kind of a strange set of syntax. So ampersand, ampersand x, ampersand I. This first ampersand says, okay, ampersand x is a macro variable indexed by ampersand I. So this is going to step through, and the first time through it's going to put x1, then x2, then x3 through x5, and that's what you see in your log. So that's how you would do an array should you ever need one in a macro. There's a few other functions. We've already talked about a lot of these. So eval does math. So if you need to do arithmetic, use eval. A lot of the string functions that you already know about from the SAS data set, index, length, scan, all work. Quote or string do roughly the same thing. Uppercase converts the case. You've already seen some do loops and some if loops. So this is just a summary of things that you might want to read about and practice some more. The final example that I'm going to take you through is producing graphical output for cluster solutions. So when I do cluster analysis, I usually mean center my variables. What that means is that the value 0 is a typical person. Positive values indicate people are above average, negative values indicate people are below average. I like to produce little bar charts like this. Unfortunately, FastClus doesn't produce bar charts like that. Here's a macro that I've written that does produce that output. All right, so I call it +1. I pass it a data set name, some variables, and how many clusters I want. So let's just walk through this quickly. I call it proc FastClus, specify the number of clusters in the data set and the variables. I save the means and the cluster assignments. Now, I usually run a proc freak. The problem with the output with FastClus is it doesn't give you percentages. Proc freak gives you percentages. Then I'm going to modify the mean output. So if you look down below, this is the output from the means. So these are the cluster means that have been spit out from FastClus. I have a little bit of code that uses some of these string functions between the length, the scan function, and the while. It's just going to walk through these variables until the end of it and produce a data set that looks like what I have down here. So I have one row for every variable, cluster combination, and I have the mean displayed over here. So that took a bit of work, and I'll let you, figure out what I did in that macro. Once I have that data set, all you have to do is call up proc chart, and you get the output, the bar chart that I showed you earlier. So that's it for